Hey everybody, so we're about to finish up the LiveView Tetris example, Bring on the Gravity. If it feels like Christmas, it's because it is Christmas Eve in Chattanooga, Tennessee, where we're producing this video. So without further ado, let's get started. Let's talk about what we're working on. So here's the LiveView. We have the bricks dropping it in from above the screen. We can basically create new bricks, and eventually it's going to hit the top. And we're going to get a game over state. Yeah, and then we see the game over view just like that. And so that much is working. So what remains to be done is work on a timer. So I'm going to go into IEX mix, and I'm going to say H. Do we have any Erlanger documentation? No. So I'm going to say timer.send interval. And I think it goes something like the count, and then the and then self, and then maybe the message. Okay, beautiful. And now we should have a few messages in our mailbox. So I want to say receive, do, take the message, and then return it like that. And then so I have a couple of those, and maybe I can outrun the timer. I don't think I can outrun the timer, but this is what we're looking for. We're looking for this to send at even intervals. So every 1,000 milliseconds, which is every second, we're going to send a tick. So let's do that, and we can actually do that in the mount. So so if we wanted to be fancy, we could do that within a connected LiveView. And now, instead of responding to this tick using the OTP underneath. So this is the key down. This is the magic one. Let's extract this and bring this down, because this is going to be a different verb. And this is going to basically take ticks, and it's going to also take a socket. And that's all that we need. So we're going to send a reply and a socket. And the socket is actually going to do drop just like it did, isn't it? Yeah, so that's exactly the same return structure that we had with def event. So let's see. I think that our LiveView should be working now. So yeah, it was probably working. Yeah, we're not dropping anymore. It looks like it's still dropping based on the keystroke. So let's make sure that we're sending a tick message on to ourself in intervals of 1,000. So we should be triggering this handle. Oh, here's a problem. It's a handle event. I want to handle info. Since this is OTP, this is going to come in on the handle info. And this guy is dropping, and that's really, really slow. Let's at least see if it works and merges into the bottom. So we're going to watch this string and see if when it hits the bottom, it's going to do the right thing. So, boom, merge, we're working. So this is the working LiveView implementation. And so to speed this thing up, we could actually send it every 500 milliseconds, and we'll see if we like that speed. So maybe every 250. See if that gives us a playable game. Yeah, I like that pretty well. And we'll set that in there. It's going to be hard to focus on the game and not on actually playing the Tetris. And there we go. And there we go. Okay, we're getting a lot of these things in a row, aren't we? Okay, so it looks like we have working game mechanics, and it looks like the scoring is working. It looks like everything is basically working. Let's go ahead and see what the mechanic looks like if we go ahead and get a game over situation. And so we'll intentionally make that worse by stacking these vertically like that, stacking them vertically like that, and stacking them vertically. Yeah, so there's my game over, and you can see that we're still sending a tick. And that tick is going to keep going, but we need to fix this game over. And so maybe we should. So in the game over, maybe we should handle something like this. Maybe something like game over, and then give. Maybe this is an H2. Say your score, and then just show the score just like that. It's funny, my wife told me that I was the Bob Ross of programming. I don't know how I feel about that. So we're going to stack these up. And so one of the things that we're going to do in a second is change our game mechanics. After we kind of put the end caps on and everything. Okay, so now we're getting a score back. And so it'd be nice to show, so it doesn't bother me that this work is actually still happening. It doesn't matter at all, actually. But one of the things that we could do is we could match, and if there is a game over in the socket, then just do nothing. A drop does nothing. And maybe that would be a good thing to do. So right now, let's go ahead and fix this. We're going to leave the debugging information in place. It's a good hint. We would not have known that we had a problem with the continuous tick without that information in there. But what I'd like to do now is have a button that says play again. So let's actually create the game in the state that we should. And so a new game is in a playing state. That looks good. So that actually assigns all this stuff. So amount sets up a new game. And so let's say we're going to do something like a new game in the play again. But initially, let's start the new game let's call this start game. So the start game sets the state to playing and then sets all this stuff. And let's have another one called new game. So the new game is going to essentially set the state to start. And it's I don't need a score. I don't need a score at that point. Oh, I have changed out of that accidentally. So okay, so now I've got a start game and a new game. So new game should be playing, and a start game should be start. And maybe this. Oh, I've got them backwards, don't I? So this is the new game. And this is the start game. So this is going to say game is starting. I don't need a score. I don't need a bottom. That is fine, just like that. As long as we have a starting game that does something like this. So this is. So if I'm starting. Welcome to Tetris. And then we'll have something like a button right here. close that out. And so now I have this one. And so when I start the game, it should be starting me in the start state. Let's see why that's so. Let's see, when I said start game, I said assign the state to starting. That's exactly what it should do. And when we mount, yeah, it's going to do start game instead. So we're going to start the game. Okay, so we have a problem. So key is not available in the template. So we do need a couple of additional. For the start game, let's just not drop this debug in there, and I think that things should work. Okay, so now we're starting the timer, and I don't think that we need. So let's say for the timer. So let's do let's say, so we need to do something with the timer where if the timer is clicking, I don't care unless the we need to look at the game state. So let's say socket assigns dot state and socket. And so now drop should do something different. So there's the drop implementation, and there's where we manage the drop. So we're only going to care if this is playing. Socket, right? And so in any other case, drop is going to do socket. So, and this is not, this is a good way to have documentation. I'm saying not playing. So let's see if that works. Okay, so now we have a start, and now I have to hook that start button up, and that's really easy to do in Phoenix. All I'm going to do is set up a Phoenix click event on that button. So so here I have the start button, and I'm going to say phx click is equal, and I'm going to say start. And so this is going to start the game. And so I should get a, if I click this, yeah, it's breaking. And the reason that that broke is that I got an event that it didn't understand, right? I got this start event, and I don't have a handle event loop for that. And so the format of start is going to look just like the format of the other handle events. So let's do something like this. Let's do handle event, and I'm going to do start, and I'm going to ignore that second parameter, and then I'm going to do and so basically I want to do a new game on socket. Let's see if that works. Yeah, so that much is working, and we're going to let that finish up. That's going to just continue to pile up Tetris pieces. We'll let them pile up there until we get to a game over state. And in the meantime, we're going to work on the game over mechanics. So, so the game over, all we need to do is add a Phoenix. We could send start to play like that. And so let's see. So I'm going to say start, and we'll let this go ahead and happen. So the last thing that we're going to do is we're going to wire up the button down to make us move faster and just give us a few points on the way down. So recall that we added a point whenever the user. Okay, so this says play again. We're going to play again, and that's working great. So the last little mechanic that we have to set for the game is this down, and that's a really easy one to set. We already have the move down implemented, so so we can actually do it this way. So we're going to do an additional handle event of arrow down, and I'm going to send that the same drop command as this, and that looks like that. So this is arrow down, and that's going to pass that. But I'm going to add an attribute to called fast to the end of the drop API. So the drop API looks like this. Okay, there's my drop. And so I get playing, and then I'm going to add another fast. So fast is equal to, we're going to default it to that. And we're going to, so there's an IO inspect that we probably don't need. So this is the drop, and the score is going to be to response.score. And okay, so I'm going to go ahead and leave this as an exercise to the user. So what you want to do is, if this, we're going to add an attribute to the Tetris drop, and if it's a fast drop, it needs to basically manage the game mechanics of a fast drop, and that should be pretty easy to do. So let's see if we can at least add to this API here. So drop to conflicts with defaults. So that means that this is probably not what we want to do. So drop to. I don't really care. If I'm not playing, I don't care about that piece at all. So in the case of the drop, we're going to say, actually, if we're let's say bonus, let's go ahead and handle that here. Bonus is equal to if fast equals, this could actually be true, couldn't it? If fast do 2, else do 0, right? And so we're going to add the score. We're going to add just a tiny little bonus into that score. So if you're dropping fast, it handles things well. And now we have to go down to where this is fast, and instead of that, I'm going to pass true for fast. And basically, in the other place that I'm processing a drop, so there's one here and there's one for tick, and that's going to be false for drop. And let's see if that builds. Undefined function fast. If fast, okay, yeah. Okay, let's see if that works better. We're going to start that, and so that's not actually picking up my keystrokes, and that's moving faster, isn't it? Okay, so our fast mechanic is working. So now we have a basic working Tetris game. I'm going to leave it to you to wrap up the other details. So a couple of things that you could do is Tetris has a list of the next elements that you could put right here on the right hand side, and you could let Tetris know what's coming up. So that's going to involve changing your Tetris game mechanic to actually track that state. And the other thing that you can do is tighten up the score a little bit. And you can add some bells and whistles to when you're collapsing that state. It actually does a little bit of a light show for you. So that'll involve doing the collapse thing in 2 phases. So I won't try to give too much of that away, but that'd be a fun problem to work on. And otherwise, there's another couple of things to work on. So as we're working, so if you see this Z, whether this Z is frontwards or backwards, it's going to have the same color, and you probably don't want that. And also the L. So this is is this one mirrored? Yeah. So these two are mirrored, but they're the same color. You probably want that to have different colors. So that implementation is shockingly easy. And I'm going to let you figure out how to do that. So basically add the colors for a Z shape and an L shape. Other than that, we are done, and we'll have one tiny wrap-up video. I hope that you'll join it and watch it so we can kind of talk about some of the design decisions that we've made along the way, and so that you can understand exactly what we've accomplished here and why LiveView made that so easy to do. So I will catch you in a few minutes.